Okay, welcome back everyone. Welcome to another Python video. Here we're solving the question called perfect number. And let's read the problem. The proper divisors of a number are the factors of a number that is equal to itself, that is not equal to itself. Okay, so example, if we have 12, the proper divisors of 12 are 1, 2, 3, 4, and 6. So a perfect number is defined as when the sum of a number's proper divisor equals number itself. So if I were to add up 12's proper divisors, you'll be getting 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 4 is 10, and 10 plus 6 is 16. So 12 is not considered a perfect number. Okay. And what we want to do in this problem is not just find if a number is a perfect number, but we want to find the total sum of all perfect numbers under 10,000. Okay. So here we go. Our solution planning is broken up into two parts. The first part is very easy. We want to generate numbers from 1 to 10,000, and then every time we find this perfect number, we're going to add it to a variable. Okay. So that would look something like this. We can say, well, we have a total sum is set to 0. Every time we find a perfect number, we're just going to add it in to this value called total sum. All right. And then for us to generate numbers from 1 to 10,000, we can write that as for num in a range from 1 to 10,000. And in this scenario here, we're not adding 1 to it or saying 10,001 because we're not going to be including that value. And then we can say inside our code, we can say, well, if num is a perfect number, right? We can say that we're going to add total sum to plus to num. We're going to take that perfect number and put it into our total sum. Okay. So I have that there. Let me just set it up like this. Like that. Right. Right now, this is not a valid Python Boolean condition, but that is a condition that we want to do. Okay, so that was something that we want to check. So I'm not ready to finish this solution yet. So what I'm going to do is even comment that out. Okay, I can leave this here because it's not going to do anything for us yet, but we will need that later on. Okay. All right. But for us, let's go into, well, if we had just a single number, how can I determine if that single number is a perfect number? So we're going to analyze this value of n. So we're going to take num, okay? And let's say we're going to use 12. We know for sure 12 is not a perfect number, but we're just going to use that as an exemplar, okay? And we want to now analyze all the numbers from 1 to n, okay? And to find its factors. So we're going to say divider is in range from 1 to num. We're not including the value of that num, okay? And then we want to have a total sum. We want to add these values to a certain value. So we're going to say factor sum is 0. We haven't found the value of all the factors as a sum yet, so it's 0. So every time I find a factor, I'm going to add that in. It's getting very similar to what we did here. So we can say if we take that number and modulus divider is equal to 0, as in it was a perfect division, so we had no remainders left over. We have found a factor. Divider is a factor. So add it to factor sum. Okay, then we can say factor sum plus equal by the divider. Okay, so as we continuously do this, we will be able to determine if it's a perfect number by going out of the for loop. So we can say end of for loop. Then we can say if the factor sum that we have after we have finished this execution of our for loop is equivalent to the number of interest that we have, then we have a perfect number. Right? Therefore, we can say that that's a perfect number, right? So, in this case, in our here, we're gonna add it to a variable. But here, if we want, we can say print f string num is a perfect number. Okay, so let's test this code. All right, so we're going to go into Python video solution bit 20. All right, I realized I didn't print out if it's not a prime number, my perfect number. is not a perfect number. We know that 12 is not a perfect number. So we went through this code right now. Sum equals 0 is doing nothing. It only is working. We're only working with these codes basically. We have set numbers to 12. We have analyzed that num is not a perfect number. Okay, so let's try putting 6. Okay, 6 is actually our first instance of a perfect number. So if we were to take that number, it says 6 is a perfect number. Therefore, okay, we were able to output this message. Okay, so notice I can change num and then use this to calculate that num is a perfect number. So what we want to do is actually just execute and copy this code inside of this for loop, and we will be able to calculate the sum of all perfect numbers under 10,000. So first I'm going to uncomment this, okay, and bring this over and bring that down here. If you want, you can highlight this all. You can do control or command square brackets to indent everything over. But num should be 6. We're going to be actually utilizing this changing iterating variable called num, which is going to represent all the numbers from 1, 2, 3, 4, 5, 6, all the way up to 10,000. So we don't need this anymore. These all num variables that we're having is going to be represented by our for loops iterating variable. Okay, so we have our num. We initialize this inside our for loop because we want this to be resetting. Factor sum is going to be resetting to 0 at every iteration. The cool thing is when num is 1, it's going to do all this calculation and then go back up, change num to 2, and execute this line again. Therefore, we get to do a whole new calculation of all this and determine if 2 is a perfect number. So this is a classic example of using a for loop within a for loop, or a loop within a loop in general, where you just take a solution to a single problem and you just apply it over and over and over again to a changing variable. In this case, our variable num is changing from all the numbers from 1 to 10,000. Okay, so it will be very annoying for us to actually output that this number is not a perfect number and this number is. So we can just completely turn this one off, turn this one off. Okay, instead of printing that, we can, well, actually it'd be cool to see what number was indeed a perfect number. But what we're going to do is take total sum and add that number that we just found is a perfect number. Okay, so we can say this is the end of outer for loop right here, and we have an end of inner for loop. So after that is done, we can say that print f the total sum of all perfect numbers under 10,000 is total sum. So a period, and now we can execute this code. So it's going to say that 6 is a perfect number, 28 is a perfect number, 496 is a perfect number. And if you notice, it took a while for our program to calculate that 8,128 is a perfect number. That is because we're going to learn that later on, that this is actually not the most efficient code, especially this part right here. And if we were to add them all up, this was the total sum of all perfect numbers under 10,000, which is 8,658. Okay. So that was a really cool example of us using a loop within a loop. All right, so please have a look at the solution and try to apply this to your daily Python practices. Otherwise, if you have any questions, you can always let me know. And as always, thank you for watching and stay classy.